The Balancing Act simulation is an interactive educational tool designed to help students explore and understand the principles of balance and equilibrium. By using a teeter-totter or seesaw as a model, the simulation allows students to investigate how different objects affect the balance of the system. The Balancing Act simulation encourages students to experiment with various objects, determine the masses of mystery objects, and learn about the fundamental concepts of balance and torque. The Balancing Act simulation begins by introducing the concept of balance on a teeter-totter. Balance is achieved when the torques, rotational forces, on both sides of the pivot point are equal. This means that the product of the mass of an object and its distance from the pivot point, lever arm, must be the same on both sides of the teeter-totter. The simulation provides an interactive platform where students can actively engage with the concept of balance. By placing various objects on the teeter-totter, students can observe how the system responds and learn about the conditions required for equilibrium. This hands-on approach helps students gain a deeper understanding of the principles governing balance. The simulation allows students to experiment with various objects of known masses and distances from the pivot point. By placing these objects on the teeter-totter, students can observe how the balance of the system changes. For example, placing a heavier object closer to the pivot point may balance a lighter object placed farther from the pivot point. This interactive feature helps students understand the relationship between mass, distance, and balance. Students can adjust the masses and distances of the objects to achieve balance. By manipulating these parameters, students can explore different scenarios and understand the conditions required for equilibrium. This hands-on approach helps students develop their intuition about balance and torque. One of the key features of the Balancing Act simulation is the ability to determine the masses of mystery objects. Students can place mystery objects on the teeter-totter and use known objects to achieve balance. By setting up equations based on the balance conditions, students can solve for the unknown masses of the mystery objects. The simulation encourages students to apply mathematical principles to solve for the unknown masses. By using the concept of torque and setting up equations, students can practice their algebraic skills and understand the practical applications of mathematical concepts in physics. The simulation helps students understand the concept of torque, which is the rotational force exerted by an object around a pivot point. Torque is calculated as the product of the mass of the object, the lever arm, distance from the pivot point, and the gravitational acceleration. By exploring how torque affects the balance of the teeter-totter, students can gain a deeper understanding of this fundamental concept. The simulation also helps students understand the conditions required for equilibrium. Equilibrium is achieved when the sum of the torques on both sides of the pivot point is zero. By experimenting with different objects and adjusting their masses and distances, students can observe how the system reaches equilibrium and understand the underlying principles. The simulation provides an interactive platform where students can actively engage with the concept of balance. By manipulating the objects and observing the results, students can gain a deeper understanding of the principles governing balance and torque. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the balance of the teeter-totter in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The simulation encourages students to develop problem-solving skills by determining the masses of mystery objects. By setting up equations and solving for the unknown masses, students can practice their algebraic skills and understand the practical applications of mathematical concepts. The simulation covers a wide range of topics related to balance and torque, including the concepts of torque, lever arm, equilibrium conditions, and the determination of unknown masses. This comprehensive approach helps students gain a holistic understanding of the principles of balance and their applications in various fields. The Balancing Act simulation is a valuable tool for teaching and learning about the principles of balance and equilibrium. By providing an interactive, visual, and comprehensive platform, it helps students understand the fundamental concepts of balance, torque, and the conditions required for equilibrium. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in physics. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of balance and its applications in various scientific and engineering fields.